So when I was in college and I took Orgo 1, I had a professor who was very much about know the exceptions. And so every test we had, it was not going to be the normal reaction, it was going to be whatever the exception was. And the type of professor who would sit back and say that, you all should have gotten this question right because, in chapter 16 it talks about it. Well, we were only supposed to cover chapters 1 through 8 in the course, and why on earth would we be reading chapter 16? So that was my experience with Orgo 1, was a teacher who was like super hardcore, like every little exception, and I felt like I memorized a lot of information. But when I took Orgo 2, I had a very good instructor, Kay Sandberg at NC State. And Kay very much was a big picture, like, what do you expect to happen? Because there are a lot of organic reactions that, if you kind of understand the flow of organic, you understand how to think about it, a lot of these reactions end up being kind of intuitive. There are a lot of reactions that you just need to straight up memorize, like the reaction of lithium aluminum hydroxide or sodium borohydride. You can't rationalize why that's going to do what it's going to do. But particularly with organic molecules reacting with other organic molecules, there's kind of a flow. And the advice she gave me, which really, for me, made her course very easy to take, was that in organic, we always have a positive and we always have a negative. And whenever we have a reaction, we're trying to match up the positives and the negatives. So the videos that follow from here on some of the videos that follow from here on are addition reactions to aldehydes and ketones. And really, we're going to talk about a lot of them, but they're all going to kind of follow the same pattern. We always have our aldehyde or ketone, and we always have some molecule HX that's going to add to it. So the X here is our nucleophile. So where do nucleophiles like to attack? Well, they like to attack positive things. And if we look at the carbonyl here, the carbon here is going to be positive, and the oxygen here is going to be negative. So every single time we add to an aldehyde or ketone, the positive part of this molecule, the hydrogen, the H+, is going to get added to the oxygen. And whatever our X is, whatever our nucleophile is, that's going to get added to the carbonyl carbon. Now, again, if you don't see that, you can just straight memorize what the reactions are. But hopefully what you'll see as you go through these successive videos is that really it's just kind of that same pattern. We're going to keep adding, we're going to keep adding. The details you need to more focus on with these addition reactions are whether or not, one, they're reversible, and two, if they are reversible, what drives the reaction forward or backwards. Because if we're going to do something like a carbon coupling reaction, we're going to add it once and we're done. But if we're going to do something where we're adding water to this, where it's reversible and we form acetyls or hemiacetyls, this is reversible, and we need to talk about the conditions where we would and wouldn't want to form the hemiacetyls. So hopefully that kind of primes you really well for what's going to follow in this video series in terms about additions to carbonyls.